Dystr is a focused platform designed for modern engineering teams building in the physical sciences. Here's a quick demo. So here I have a project called System Controller that's open. You can have as many of these kind of projects as you'd like. So in this demo organization, I've got a bunch of projects here. I'm just going to click into the System Controller project. And here are all the calculations on the left that I'm doing as part of that project. The calculations are executed through deterministic code. So this is the exact code that's being used to run that calculation. I can tweak the values. So as an example, we ran this calculation with 900 ohms. Let's run it again with 500. Hit run. That's all there is to it. It's just like an Arduino. You just work with a small piece of code that's relevant to your analysis, and that's it. Here's all the history for that calculation that I just ran. Here's the output from this last run. Before I executed it, I changed this value. No need for Git or any of these software version control systems. It just works. You can see what everyone else on the team has done for this particular calculation. If I want to iterate on it with something more involved, super easy. I can just use the model. Let's say I want to compare more than one resistor. I can have as many calculations like this as I'd like in a project. I can fork them off of each other, start new ones, super simple. This entire environment is accessible to everyone that has permissions on the project. I can just click and share. I didn't have to install Python or do any complicated setup to get going. This is all happening in my web browser. There's an Ubuntu virtual machine that's under the hood that's set up and ready to go, isolated for each project. Every time someone writes something, it just works. No need to account for differences between people's environments. For those that prefer not to read code, we translate exactly what the code is doing into a math representation. So you can just read it instead and get a good understanding of what's happening in the execution logic of the code. With the compute area of the product, we give your team a place designed to do engineering calculations in the modern age. No more MATLAB scripts everywhere. No more having to become a software engineer to use the latest tools. And of course, you can run calculations off of datasets as well. For advanced users, this works off of structured databases like HDF files and SQL databases as well. I can just drag and drop the files here and I'm good to go. And as a bonus, all of our datasets are kept right where we analyze them. No more scattered datasets and scripts. Soon we'll let you run calculations like this in the background, so you can set something up like, repeat this whenever a new dataset comes in, or run this on a schedule, etc. I've dropped in some datasheets of the project here too. What Dystr has gone and done is semantically index them, so it's easily searchable by the models that run my project. I'll show you how this is useful in just a second. So I'm going to head on over to the chat area. Here I can give instructions to the model for it to perform a task for me in this project. For example, let's say I wanted to find out some detail about a part we're using. I'm just going to ask it, and it'll dispatch a model to find it for me. As you can see, it's located the exact spot in the datasheet where it's referenced. So I don't need to dig through all these pages. I can just go straight to the project and just find exactly what I'm looking for. The search extends across project contents. Like let's say I want to find some clause in a regulatory requirements document that I need to hit, for example. Now let's take this a bit further. Let's take the calculation we were just doing and use our notes from earlier to write an email to the team sharing the results. Super simple. Done. Now let's send it out. So LLM models are effectively taking a forward time step in the future of a storyline they're running. One where they're useful is when you're chatting with them, where they're effectively finishing the storyline of a conversation. Another way that's super useful is to have them run somewhat like a character in the HBO show Westworld, living the same day in repeat, so to speak. They wake up with a set of instructions and a ticket for the day, execute it, and then stop. You can create as many of these as you'd like to run inside your projects. For example, I'm going to tell this worker that I'm going to copy it into our team emails, and I wanted to extract out everything marked urgent and keep a note where we can all see it in the project. I turn on its email address, and now it wakes up and runs the instructions I've given it each time it gets an email. Let's see it in action. You can see that the worker did exactly as we had instructed. It ignored the happy birthday note and started the urgent project tracker that we wanted. With a few sentences, I've automated something tedious and annoying. This also works with anything that can send a message over HTTPS. So anything that supports sending webhooks like Jira, Microsoft Teams, etc. Here's one that was set up to trigger when something happens in Jira, for example. And you can see that the full ticket details was sent by Jira to the worker here for it to process. I can also have them set up on a schedule. For example, let's say I want to fetch the wind speed data from this government table that's published online and keep it in a nice structured way that I can work with over time. Here's what the table looks like for reference. So I'm going to set up a worker to fetch it and put it in a database for me. Literally just going to write out what I want it to do. Done. Let's test it out. As you can see, it is fetching the table from the website as we had instructed, and then it has crafted a SQL query to insert that data into a SQL database inside the project. I didn't need to learn SQL at all. And now let's set it up so that it does it every hour, every day. Super simple. Welcome to a world of English language programming. Now we're just getting started with workers. Soon you'll be able to sequence workers and compute tasks to run one after each other, like a process flow of deterministic and AI inference. Imagine a day where you can just write down the engineering processes you have and have them run in the background by an army of AI workers at your command. A new data set drops in, a series of determinate calculations are triggered, anomalies are flagged, the right people are sent emails, exactly as you currently do it, just on autopilot. Eventually, since these workers are running in a project sandbox with a computer private to it, you'll be able to give instructions to workers to operate tools like SolidWorks and NX installed on the project machines as these models advance. Thank you for watching, and head to dystr.com to get started.